We have one last presentation from Junior Joseph. I don't know if he is online. He is online, okay. Junior, can you hear us? If yes, you can proceed with your presentation. The presentation is called a QUIC-Native Identity and Federation Layer for African ISP. The floor is yours, Joseph.
Thank you so much, moderation team, and a fantastic presentation, gentlemen. Can you hear me?
Yes, we can. Please proceed.
Thank you. I'm joining you all remotely today. I can feel the immense engineering energy in that room. And ladies and gentlemen, we really need these automated networks because once networks are automated, it means that we can all host data that is also intelligent. So over the last few years, looking at our infrastructure, I've seen that we've got a problem. We do not own much of what's going on from the equipment point of view, and also to the services that are being run on that equipment. So today I'm going to present an integrated blueprint of that's going to meet African ISPs where they are through QUIP. It's a brokerless federation protocol over QUIP. I wish I could send my, oh yeah, it's already there, thank you. My slide is there. So can you please go on to slide number 2. Slide number 2. Okay. To be completely honest about the status quo that we have, the way that we handle identity federation across networks today is fundamentally broken, and it socializes severe operational pain again across our entire industry. Right now, QUIC is frozen behind HTTP3 with zero raw stream control. We are completely logged into web PKI, where massive foreign OAuth and OIDC brokers our own identity namespace. On top of that, our servers are drowning in hidden buffers from gRPC and REST queues that cause sudden out-of-memory crashes on edge hardware. And the biggest elephant in the room, that is the DNS-sec barrier. I've been following since yesterday. I'm glad to say that we've got around 44% penetration of DNS-sec globally. So it's a bit better than when I was actually doing this presentation. I was expecting it to be around 1.3%. But you know, this problem of rolling it out, it makes protocols like Jane completely undeployable globally if DNSSEC is not there. So without a built-in causality primitive, systems rely on vector clocks that scale poorly or fall back to last right wins policies that silently block data. As a result, we inherit head-of-line blocking, hidden buffer bloat, and broker-dependent identity. QUIP changes this entirely because we remove HTTP and DNS and web PKI from the critical path. Can you please go on to slide number 3? So why does this matter so deeply to the people sitting in the Mara Ballroom today. Because right now, our digital infrastructure is tethered to decisions made entirely outside our borders. I'll quote from Professor Bulelani Jili from South Africa. We recently noted Africa's digital stack is trapped between foreign physical hardware and foreign application platforms, leaving local actors dependent on external players. Let us be clear, Africa must not be passive, a passive recipient of rules made offshore. We cannot wait decades, for absolute global DNS rollouts before we secure our routing layers, local deployment, as it sits at around 1%. We cannot continue to rely on foreign certificate authorities like Let's Encrypt or DigiSet to control trust for our local ISPs. I'll give an example of Potras, a regulator in Zimbabwe. It's licensing data controllers, and this covers attestation of the data that they're actually controlling. But we lack the technical infrastructure to actually enforce it. So QUIP is here to flip the script. It gives African ISPs the technical architecture to become local trust anchors, not just transit pipes. Self-sovereign identity works natively without DNSSEC. So this allows Potras licensed controllers to run witness servers for seamless cross-border peering without a single foreign broker dependency. QUIP was built for the exact constraints that African operators face every day. And will you please move over to slide number 4. So why now? Why QUIP now? It's because the pain of the status quo finally exceeds the political and engineering cost of changing it. Global regulations like the EU Digital Market Act are forcing gatekeepers to open up the third-party federation, while consumer spaces like ActivityPub have proved massive global demand for decentralized systems. On the infrastructure side, AI inference and real-time apps have turned RAM and tail latency into first-order operational costs. Allocating 10 gigabytes of data per server is no longer free. So crucially, the technical primitives are mature. We have stable production-grade quick stacks like Queen, SN2, S2, and QUIC that are datagram ready. Modern languages feature high-performance ED25519 and CBO libraries. What used to be an academic research project can now be implemented by a single engineer in, say, 3 months. Primitives were ready back then. The incentives were not, but they are now. Please move over to slide number 4. Or number 5, sorry. So what exactly is QUIP? It is a brokerless federation protocol operating directly over QUIP, providing self-sovereign identity, causal consistency, and explicit application back pressure. As you can see on the slide, we achieve this through 4 core primitives: ED25519 portable identity, dotted version vectors for causality, a key transparency and trust on first use hybrid model, and 4 distinct tiers of queueless transport. Our key differentiators are absolute. Unlike HTTP3 and gRPC, we have 0 hidden buffers. Unlike ActivityPub, no broker owns the namespace. Unlike DAME, we are 99% deployable on day 1 without DNSSEC requirement. And unlike legacy clock vectors, our causal tracking scales to the number of active writers, not total network nodes. And may you please move over to slide number 6. Let's look at how identity works in QUIP. Your 32-byte ED25519 public key is your identity. There is no domain authority and no external certificate chain. Look at this claim structure on the screen. Let me just see. Oh, it's a bit behind. May you please go to slide number 6. It's a slide showcasing the exact code box layout for seedboard tagged key claim structure containing node ID, timestamp, a domain hint, and a signature, followed by a list of self-sovereign properties. Looking at the key claim structure on the screen, it contains a node ID, a timestamp, a domain hint, and a self-signature. Noting that notice that the domain name is purely a hint for routing advice, not an ultimate authority. If a registrar gets compromised, you do not lose your identity or your account. You simply update your routing hint while your unique node ID remains identical. And if a private key is lost, the system is intentionally unrecoverable. There is no backdoor recovery mechanisms. You simply spin up a new identity. Let me try and do screen sharing, and then I can. Slide number 6.
Junior, do you see the slide that you're looking for?
Yes, I've seen it, yes. Can you see the slide?
A portable identity, yes, we can see the slide.
Yes. So that's the structure of how the identity looks like. There's a node ID, a timestamp, a domain hint, and a signature. So let me do this.
Joseph, the technical team is telling me that you should be sharing your slides. Can you share your slides
Yes.
from where you are?
You know, I'm sharing the web tab that is got the slide on. Can you see it from my side?
No, we cannot.
You cannot.
Are you using a second screen?
No, I've got one screen on.
Okay. Can you put that in presentation mode or large? Yes. A presentation mode. We can see your screen, but it's not in presentation mode. Or full screen. Yeah, full screen. Okay. Maybe, yeah. Yeah.
That's
Now,
better.
yeah. Please proceed.
Okay. Yes. So this is the key claim structure. All these they are self-sovereign properties. You sign your packet. Only the private key holder can assert identity. And the domain hint is only for routing advice. It's not an authority. Once a registrar is compromised, you can change your hint to another registrar, and that doesn't affect your identity at all because your node ID stays. And then for key loss, it's unrecoverable intentionally. So you can just create a new identity. Then there's no external infrastructure required for the first contact. You pin your key on first use. So I'm just going to briefly describe what TOFU behavior is. It's trust on first use. Once a key claim is seen, it's accepted and pinned by a witness, and then subsequent claims must match the pinned key. A mismatch without a rotation degrades the QUIP's mode. And then the user is alerted. No silent man in the middle attack. And then for DNS hijack, we've got a defense for that. If an attacker presents a false key claim, trust on first use remembers the legitimate key. False claim lacks witness confirmations, and the result is a detectable denial of service, not a silent man in the middle attack where you don't have access to your data. And then key transparency gossip. Peers broadcast witness statements to build a distributed trust among themselves without a central log. So the witness statement has got a SIBO tag of 65536 and a subject node ID, a domain hint which is just used for discovering the node, and there's also an ASN for witnesses. There's also a prefix for the IP block that the ISP is actually controlling, and a timestamp of when the packet was sent, and then a time to leave of 30 days until reattestation is needed. Then we've got the witness node ID also there, and a signature of the witness. So the life cycle of a verified key from 0 to 6 days, and not 3 witnesses, we only use trust on first use. Then after 7 days, we use we actually stamp it as a verified identity, and then this identity expires after 30 days. Then it needs re-verification again. And if ever a user misbehaves on the network, it is revoked and a violation receipt tombstone is issued across the network. Also, a 7-day age requirement prevents instant Sybil attacks. 30-day validity forces periodic re-attestation. So it is always supposed to be valid. Then for casual consistency, the data that is actually broadcast through the network, QUIP guarantees that everyone sees events in the correct order. There's no central server that's needed there. There's an analogy of Alice writing an update, and then Bob sees the update, and also Carol sees the update. All 3 agree on this exact same order automatically. The WhatsApp analogy, you see how WhatsApp read receipts work in a group chat, but not for federation. They are centralized. Everyone knows who saw what and in what order. No server decides. Peers agree automatically via dotted version vectors. So why does this matter for ISPs? 2 internet exchange members edit a root object at the same time. QUIP merges both edits deterministically, and there's no last write wins, which actually causes data loss. There is no central database required. Everything is on the network fabric. Then QUIP uses a queueless transport tiers. There are 4 dedicated tiers designed to eliminate head-of-line blocking like in TCP, and it also ensures deterministic RAM usage. Here's a table of how the tiers work. So QUIC's stream 0, it is used for handshake errors and key transparency gossip. Then there's also queue policy. It is a queueless transport, so this may actually block. And then reliability, it's a reliable stream. Then we've got the second tier, tier 1 sync. It's a stream for dotted version vector exchange and anti-entropy. It is queueless, and it also throws a error try again on Windows 0 on its policy, and it's also a reliable stream. Then the third stream is T2 for bulk data exchange. It starts from stream 8, 12, and 16, and so forth. It sends messages and documents. Its queue policy has got error try again on Windows 0. It's also a reliable stream. Then we've got the last one, T3. It's for ephemeral events. On the transport, it uses quick datagrams. You can use it for media, telemetry, presence, etc., etc. And since it's ephemeral, you can drop if it's congested. So this means that it's an unreliable stream.
Ça va, tu m'entends?
Yes.
Maybe to let you know that you have 2 minutes
Okay. Thank you. And then also QUIP has got a back pressure contract. QUIP converts a hidden memory growth into visible back pressure. Currently using HTTP3 and gRPC framework buffers in memory. Sender never sees an error try again. RAM grows until out of memory queue occurs. Then the tail latency is also unbounded. And this cost is socialized back to the SREs. Then the QUIP contract, it's got a tier 1 and tier 2, which throw the error try again in Windows 0. Then there's no application layer buffering. Everything is on the transport. Then there's also deterministic RAM that is used per connection. Tail latency is the first class signal. And optimization burden shifts back to the developers. It does not sit on your browser. Like we already spoke, that a 10 gig of RAM cannot just sit around anymore these days, since AI inference and real-time apps, they depended on it. They demand it, actually. Then server authentication modes. There are 3 modes for different deployment realities. Compat is actually the default. In Compat, we've got PKI, Bootstrap Plus, key transparency, and trust on first use for identity. This one is the general deployment, which is actually 99% ready for deployment. Then there's strict mode, which uses DNSSEC, DAME, key transparency plus TOFU, trust on first use. This is a high security. It is used mostly in regulated environments in your banking sectors, health, etc., etc. Then in the previous draft, we had the legacy mode, but it has now been deprecated. It was only using WebPKI, but from version 2 of the draft is going to be removed. So why is not Jane a default on QUIP? It's because there is no 100% global deployment, and this makes QUIP undeployable if it were to use Dane as the default. So KT plus TOFU provide equivalent security, 3 independent witnesses without the deployment barrier of Dane. The handshake negotiation capability bit masks are actually in the handshake. Bit 0 is key transparency and trust on first use. Bit 1 is Dane, strict Dane, and then bit 2 is tier 3 datagrams. So once there is an intersection of a mismatch, that is, there's an error of a profile mismatch, and then the handshake cannot continue. Then we've got some security properties that QUIP defends against. It defends against domain impersonation, self-signed by self-signed key claims and key transparency witnesses. It also defends against replay attacks using message ID plus sequential reset terms being binding, and also DNS hijacking. If a DNS hijack is discovered, it is detected to become a denial of service. Then there's a split brain or fork of the data that is on the network. The dotted version vectors have got a deterministic merge. Then gossip amplification, we've got a time to live and rate limits for the data that is being broadcast across the network. Then registrar compromise, we've got no single authority that can silently rotate keys. Because of time.
Thank you very
so much for the opportunity.
Yeah, thank you, Joseph. Can we have a round of applause to? There is a lot to unpack. Sorry, Joseph,
Yeah,
but
as much,
time,
yes, it's okay.
yeah, the time is against us. But thank you for these insights. I think there is a lot to unpack here, but probably to give the opportunity for one or two questions quickly before we break out, I would welcome
Yes.
anyone from the floor. If there is one burning question or two at maximum, but we don't have much time to ask. Yes, thank you.
Hi, Joseph. Joseph, congratulations. I mean, it was an absolutely amazing presentation, and I'm hoping the technical details work out. I'm going to ask, although I've got part of the answer in front of me, but have you managed to get any traction with the IETF process? I can see in the data tracker that the document was last updated there on the 5th of June, but just if you could give some sort of insight as to, where you are with the IETF process and getting your work in front of them. The other thing that I'd just like some insight on, it follows from the earlier presentation on cryptographically relevant quantum computing. I'm assuming all of the instances in which you're using digital signatures of any shape or form are the most recent and relevant, and we're not going to have the same challenges as with DNSSEC that the previous speaker described as in denial with this. So those are my sort of two questions, but honestly, congratulations on an amazing presentation. Thank you.
Thank you very much. Let's take those only two questions for the sake of time. Junior, you want to react on that?
Yes. I can give the answer to the first one. Actually, the draft was first put on in May. Then that was version 00, and we had to make some serious changes because of the DNSSEC problem. Then we introduced key transparency and trust on first use in version 1 of the IETF draft. The document is already on the IETF under dispatch because it's an individual submission. So hopefully maybe we can get one of the area directors to actually sponsor the draft, or maybe we can get a home transport working group or a security working group, but we'll see how it will go. And probably there's an IETF interim meeting for dispatch and security dispatch on the 30th of June. So I hope I'll get another opportunity to actually present more in-depth information on the protocol. I'm sure this might be one of the first protocols that have been created in Africa recently. I hope it's going to also change everyone's lives in Africa.
Thank you, Thank you, Joseph. Another round of applause. Thank you. The floor is back to you. Thank you.